All right, guys, this is going to be the last video here on chapter 4, one of the bigger units that we're going to have. So one of the last control mechanisms that we have is called blocking. And so I'm going to add something up here on the top, just like a definition of what a block is. So when we block, what we're saying is a group of experimental units that are known for the experiment to be similar in some ways, or some way or ways. Okay. That is expected to offset the response variable. Okay. So for example, gender is typically a block, right? Age is another good block. Those are kind of some ideas. So now let's say we're looking at many students enroll in prep courses to improve the SAT scores. 20 students who have taken the SAT once have volunteered in the experiment, comparing online and classroom prep courses. So what we can do is we can, instead of just doing a completely randomized designs, or just doing like, number of the students 1 through 20 and then just randomly place them. What we can do is we can do random assignment that occurs within each block. And like, well, what's the point of doing blocks right now? Is that we could look at, and this kind of leads to the next question here. Like among the 20 volunteers, 10 are in pre-calc, 6 are in algebra 2, 4 are in geometry, right? And so what you could do is then you could use the classes or the classrooms, right? The classes that these students are in as blocks, right? And so then what we could say is that from within the 20, within the 10 pre-calculus students, right, we're going to divide those up. So 5 will go to the online, 5 will go to the regular classroom. Out of the algebra 2, 3 will go to the online, 3 will go classroom. But the geometry 2 will go online, 2 will go in the classroom. And that's how you can kind of divide your divide your sample by using blocks, right? And the reason why, and then I can add in here. So if we were doing just an SRS, we would number 0, 1 through 20, and then use a calculator to get random numbers for each group, except this does not count for math abilities, right? People who are in pre-calc are probably going to be better off in math than people who are not in pre-calc. Okay. So again, that leads into the next thing. Kind of already talked about it. What is this? Why will this cause problems? Because people who are in more advanced math classes will probably do better on the SAT. Okay. So how do we address this problem? I already talked about it. But what we can do is, I'm going to write this out, is out of our, so we number the 10 pre-calc kids, right, 0, 1 through 10, and use random assignment to assign 5 students to online and 5 to regular. Okay, and then you repeat that process for the other classes, right? I'm not going to write that out, but you kind of repeat that process again. Okay, this we'll look at in class. Let's see. Okay, this one I'll do in class as well. So what is the benefit of blocking? I'm going to just kind of skip down a little bit. What is the benefit of blocking? Again, it's an additional control measure essentially, but using what we call a random block design allows us to account for variation in the response that is due to the blocking variable. So in the previous example, it would have been math ability would be a blocking variable. This makes it easier to determine if one treatment is really more effective than the other, right? Again, it's just another way to control for confounding variables, right? Your math ability would be a confounding variable if we didn't do it. If we just did an SRS, right? The fact that 10 of the 20 students were in pre-calc is obviously going to have an impact. In general, how can we determine what might be the best thing to, what variable to block on? For here, you control what you can. Whenever you can, control what you can. Okay, so, and then you can block on what you cannot control. Okay, so you couldn't control what classes students have taken. Okay, so you can control whether they're in the online or the, you can kind of like set that up, right? But what you can't control is what students or what class students have taken. You can't control something like gender, right? You can't control something like location, right? So those are things that you block on, right? So then, okay, well, we're going to block on whether you go to Dexter schools, Ann Arbor schools, Saline schools, etc. Right? Because we can't control that, so that's something we can do. And randomize, and then you can randomize those to create comparable groups. Base blocks on most important sources of variation. Okay, so what are some variables that we can block for in the caffeine experiment? Gender being one of them. Okay, that's probably the biggest one. The amount, I'm gonna write this in a, but let's say the caffeine tolerance, right? Like if you know that, maybe fill out a survey, be like, how much caffeine do you drink on a regular basis? So you can so you can't control that, right? You can't like stop people from drinking caffeine, but then you can kind of block on, okay, well these people drank 4 cups of coffee a day, so, or et cetera. Those are kind of some examples. What is the difference between blocking and stratifying? So here, stratified is done only when taking a sample from a population. A blocking happens when assigning units to treatments in an experiment. So it's more like, when are you doing it? It's kind of the idea there. Okay, we'll look at the popcorn study in class. What is a matched pairs design? Okay, matched pairs is another type of, it's a common type of randomized block design for comparing 2 treatments. The idea is to create blocks by matching pairs of experimental units. Okay. Then we use a chance process to determine which number of the pairs, or which like people within the pairs receive a certain treatment. Think of each pair as its own block. So common example that we use here is like students have a class rank, right? Within your class. And so student 1 and student 2 are pretty, like if you're the top student or the second best student in your class, you're probably pretty similar in most aspects of life, right? And so you could use those first 2 people as a match pair, right? And then you could use random assignment to determine which groups they go into from within that, right? That's kind of the idea here. And so some other examples you can do, same person on a different day, right? That's another example of a match pair. Same person, but using different parts of the body. That's another one. Or 2 similar people. That's kind of what I just talked about. Here, I'm going to fill this in so you can kind of see it. So basically, what can you say about your experiment, or how can you generalize your experiment based on what you did? So if you were randomly selected from a population and you were randomly assigned, you can do 2 things. You can do cause and effect, and you can make inference about the population. Random assignment is going to lead to your cause and effect, right? Selected from a population means that you can infer to your means you can infer beyond the scope of your sample. So the one below this, right? So you didn't decide to randomly select from the population, so you can't make inferences about the population, but you can infer about cause and effect. Here, you can say about the population, but you can't do cause and effect. And on the last one is both. No-go. Okay, so when you randomly assign, you're creating groups that are similar, right? Not more accurate, but similar. And so as a result, then whenever you implement any control for all other confounding variables, and so then when you implement your treatment and then you see the result, if the results are significant, then you can say that was cause and effect. Okay? And the way to make sure you can say that about everybody is to be like, okay, well, did we get something that's representative? And to do that, you need to randomly select from the population. Okay. And this last problem here we'll look at together in class. And that's the end of the videos, guys. That's all of chapter 4. As always, if you have questions, please let me know. But if not, have a great rest of your day.